What I want to start with is just the very basic concepts. What is vortex-based mathematics? What is it saying? What are its applications? Well, first of all, vortex-based mathematics, his original claim was that he had tapped into and could model mathematically a previously unobserved, invisible energy. Okay, that energy is referred to by many names and has been by many people. It's been called tachyons or monopoles. You might call it gravitons. You might call it radiant energy, chi, prana. You might just call it energy, or E, like as in E equals mc squared. It is the motive driving force behind all of reality. It is the initial impulse, positive force behind creation. Okay? This energy is characterized by its linearity. In other words, it moves in a straight line. Every bit of mass, Einstein's relativity will tell us everything with even a slight bit of mass, even a photon, okay, which is supposed to have no mass, but even a photon coming from a distant star was seen to curve around the sun, okay, proving that relativity existed. So this shows that all mass, all matter is in a curved motion, a relative motion. This energy is different from that. It penetrates everything, nothing can resist it, and it leaves a grain on everything. It is undecaying and eternal. Okay? And it is the control and standard upon which all of creation is based. So that is what I want to describe. Here is, in this symbol before you, those of you who are familiar with the math have seen this. Marco refers to it as the symbol of enlightenment. It is a mathematical decryption of what's known as the most great name of God in the Baha'i faith. I came to this work initially because of my lifelong search for the understanding of how to intonate the most great name of God. But without going into religious mysticism, I'm simply trying to point out that these numbers and everything that I'm going to show, even what this energy really is and does, the closest thing that you can get to it is sound. What this is a model for sound, for resonance, for harmonics. Numbers are harmonics. They're musical. Okay? They are polarized. They create color. They create all the effects that we see. Okay? And these are just simple whole numbers. I'm not talking about any kind of esoteric or complex numbers. Okay, so around this circle, we see all the numbers we are familiar with. We start here with 1. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. All right? So those are all the single-digit numbers known. I don't know of anyone who's ever, in any of the talk I've ever done, suggested another single-digit number that exists. Any other number is going to at least create double digits, triple digits. And what we're showing here is that if you add those numbers back together, which is a common practice in numerology and computer science, it's called finding the digital root. Okay? What it does is it reveals an underlying pattern underneath any bigger number that you can find, or any infinite series. Everything has an underlying pattern to it, and these single-digit numbers will give you the underlying pattern. And what we're looking for in nature is patterns. When we want to model fractals, self-similar forms, all this is based on patterns. And this is a way you can create all these patterns, and you can model a higher dimensional energy, okay, and show how it's creating those patterns. So these are our simple numbers, 1 through 9. We're going in a clockwise, right-handed direction around the circle, okay? So let's just, what we're saying here with this symbol is that With it, you can do all the functions of math, which is addition, subtraction, division, and multiplication. There's no other known functions of math. All of those functions of math can be done instantaneously, simultaneously, and they can be shown to be revealed in one single map, which can do every function of math, which can model every principle of physics, which can model chemistry, the periodic table, which can model genetics and biology, that you can do every function of math as one. So I wanted to show you how those work and how they relate to this symbol, and then what this symbol ultimately produces, which is the real goal of the work. Okay? So let's start here with 1. It's a really easy number. Oftentimes they say 1 is the loneliest number, or we might think of one God, one universe. It is a cohesive number, a unity. Okay? So we start with 1. What is 1 doing on the symbol? Well, if we draw a straight line connecting it to the next number, it goes to 2. And what that is called doubling. 1 doubled becomes 2. Okay? 2, if it doubles, and we follow this line again, becomes 4. 4, if we double, again following our line, becomes 8. 8 doubled then is 16. But here I have a 7. How come is that? Because if we add 6 and 1 together, we get 7. And again, we're looking for underlying the pattern, underlying the big numbers, the sequences of numbers. We have patterns of single-digit numbers. So when we get to 16, 6 and 1 is 7. So that's my next number. 16 doubled is 32. But I have a 5 here. But then again, if I add 3 plus 2 is 5. Okay. I could just as well say 7 doubled is 14. 4 plus 1 is going to be 5 too, so it doesn't matter how I do it. Okay? Let's stick with 32 though. 32 doubled is going to be 64, bringing me back up here. But here I have a 1. But 6 plus 4 equals 10, and 1 plus 0 comes back to 1. Okay. 64 doubled is 128. 8 plus 2 is 10, 10 plus 1 is 11, and 1 plus 1 is 2. 128 doubled is 256, which reduces back to 4. 256 doubled is 512, reducing back to 8. 512 doubled is 1024, which reduces back to 7. 1024 doubled is 2048, which reduces back to 5. No matter how many times I go around, no matter what numbers I take, and no matter what combination I do, in other words, I could say this is 11, where my 2 is here, because 1 plus 1 is 2. 11 doubled is 22, and 2 plus 2 is 4. There's no possible way to break this doubling sequence. Why is that significant? Okay. Because doubling is how vibration and motion occurs. And this energy, which is going to be represented by our number 9, this tachyon, monopole, what we're going to call etherons, this energy is the source of all motion, of all vibration, of all time, of heat. It's the source of life. It's what keeps everything moving forward. Okay? It's what keeps creation doubling. What are examples of doubling? We could take cell division. Okay? You can see you have one cell, which becomes 2, 4, 8, 16, 32 cells. They stay all together as an aggregate until they reach 64. At 64, all the cells become individualized. They can become brain cells or heart cells, right? So at 64, you get each cell becoming an individual. In other words, showing the parallel between the 64 and the 1. Okay, this is why 64 is a cycle in the Mayan calendar or in the I Ching, all relating back to the 1. It's a completion of this cycle, which we call a bounded infinity. It's an infinity of duration, constantly moving, not necessarily an infinity of direction, because it has an axis, which we're going to talk about. Okay, what else doubles? How about music scales? From C to C to C is doubling. Okay, doubling harmonics. You go from 440 to 880, or depending how you're setting your frequencies. You have doubling in harmonics. Okay, so there's many, many examples of these numbers of doubling and how that works in creation. Take, for instance, nuclear reactions. You have 1 neutrino, which liberates 2, which liberates 4, which liberates 8. In other words, neutrinos are working on a doubling sequence as well. Sometimes it's called a chain reaction or a geometric progression. Another example of doubling, the binary code in computers. Okay, I can go on. We could talk about the 64 codons in the DNA. All of this highly related. Okay, but let me continue with our basic number sequence. What happens if I follow my track in the opposite way? Well, if I'm doubling this way, I must be halving in the other way. So let's find out if that's true. Half of 1 is 0.5. Again, back to my 5. Half of 0.5 is 0.25. 2 and 5 equals 7. Half of 0.25 is 0.125, which equals 8. Half of 0.125 is 0.0625, which reduces back to 4. Okay? Halving works the same way. I can't remember what half of 0.0625 I think is I forget what the number is. Anyway, you can do it. You can make the calculation on your own. You'll find no matter how far you go, you can half. I could do it just as well. I could say half of 10 is 5. Okay? Half of 5 is 2.5, which equals 7. Okay? So you can do it any number of ways, and it's always going to work. This is an infinite series of halving. Very significant. Okay? Because when you have a motion in one way, you're going to have a trailing motion in another way, and we're going to talk a lot about that and how it works. This black line that you're seeing here is the pathway that everything takes that moves in creation. It is the spin continuum that the universe is on. It's why the universe is always moving, but it's never actually going anywhere. It's on a treadmill. It's a bounded infinity. All right? And you're going to get real familiar with that concept of the bounded infinity. It touches everything we're going to do. But I don't want to get too stuck on that. I want to take a look at some of the other properties of my symbol. Now here I've talked about 6 numbers. 1, 2, 4, 8, 7, 5. Back to 1. What about these numbers? Now I have 6 and 3 and 9, and they're connected by this pyramid. It's only connected at the top, by the way, never connected on the bottom. So this triangle or pyramid here connecting the 3, 9, and 6. Well, let's find out what happens with these numbers when they start getting mathematical functions. Let's take 3 at first, since it's the smallest, the simplest. What happens when I double 3? 3 doubled becomes 6. Okay. Well, 6 doubled then becomes 12, and 2 plus 1 is 3. 12 doubled becomes 24. 2 plus 4 is 6. 24 doubled is 48. 4 plus 8 is 12, and 2 plus 1 is 3. 48 doubled is 96, which comes back to 6. Okay? So no matter how far you double these, you're oscillating, 3, 6, 3, 6. Halving would be the same. I could say half of 6 is 3. half of 3 is 1.5, which is 6. Okay, you could do it any number of ways. Half of 30 is 15, which is 6. No matter which way you do it, halving or doubling, 3 and 6 are oscillating back and forth. None of these numbers do that. Before you can get to another 1 on this doubling path, you've got to come all the way through these other numbers. Only 3 and 6 are oscillating back and forth, just like magnetic fields, okay? Like a pulse, like a representation of duality, of opposites, in and out, to and fro, back and forth. Okay, that is how the 3 and 6 work. We could call them and refer to them as magnetic numbers. But how come if they're oscillating back and forth, they're not connected to each other by a line? You see there's no line here. And in fact, my 6 has to go up here before it can come back down here, and same with my 3. They're both connected to the 9. Now I've hesitated to get to the 9, but in fact it's the most important number. Or we shouldn't say that. Maybe we should say all the numbers are equally important, but the 9 is really the king of the system, or the queen of the chess game. It is the control for everything else. So what is the 9? Well, what happens if you double 9? 9 doubled becomes 18, right? 18 doubled is 36. 36 doubled is 72. So if you add any of those numbers together, 18, 36, 72, they always equal 9. What about if I half 9? Half of 9 is 4.5, which equals 9. Okay, half of 4.5 is 2.25, which equals 9. 5 plus 2 is 7, 7 plus 2 is 9. So no matter whether I double or half, the 9 is never changing. It's forming an axis here that's polarizing all of these numbers. Because in this system, we're actually able to give polarity to numbers. So I've shown you one function here. We've been talking about, or two functions you could say. We've been talking about doubling. We've been talking about halving. But let's go back a little bit simpler. Let's try to understand, before we go too complex into physics, what are these numbers and what do we mean by the functions of math? Okay, so we'll start simply with multiplication tables. All right, let me bring up my next board. Okay, now here I don't have my lines drawn in. I'm sorry for the primitive board, but you'll have to bear with me. Here I'm showing you multiplication tables. Now we started with my 1. Okay, the number 1, when you multiply it, what does it do? 1 times 2 is 2. 1 times 3 is 3. 1 times 4 is 4. 5, 6, 7, 8, 9. After that, I'm simply going to repeat. If I go to 10, 1 plus 0 comes back to 1. 11, back to 2. 12, 3. 13, 4. 14, 5. So no matter how far I multiply, when reducing to single digits, I'm constantly going to have this pattern. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the only number that will make that pattern. 1 is the only multiplication series which goes up in increments of 1. So it's unique. One of the important things in the system to remember is that there's never any redundancy. It's never doing the same thing over and over, or the same thing twice, you could say. Exactly. So 1 is the only number which goes up in increments of 1. How about if I come over here on the other side of my 9? Well, you can notice something pretty simple right away with my initial symbol. These numbers that are all lined up straight across, we can notice they all equal back to 9. So 8 plus 1 is 9. 7 and 2 is 9. 6 and 3 is 9. 4, 5 and 4 is 9. So 9 is always forming the center line that separates and polarizes the numbers. And so it's actually turning these numbers into mirror images, or right and left. It's giving a polarity to everything. So when I start to show these multiplication tables, you might say, well, what do you mean by mirrors? Because the 1 and the 8, they don't look like mirrors. Okay? But we know we have something called spin symmetry or mirror imaging in physics. You could say if I have a positive particle going one way, then there should be a negative particle. There should be mirror imaging between things directionally, or just like between right and left. Your hands are mirror images. And we don't really have 10 fingers. You have 0.5, which is half of a whole. It's 100%. So when I have 1 going up in increments of 1, well, my 8, what happens is I'm going down in increments of 1. So you can see immediately that I have polarity. When 1 is positive, going up, 8 is negative, going down. Okay, so 8 times 2 is 16. 6 and 1 is 7. Okay, 8 times 3 is 24. 2 plus 4 is 6. 8 times 3 is 32. 3 plus 2 is 5. 8 times 4 is 40. Wait a minute. No. I said 8 times 1, 8 times 2, 8 times 3, 8 times 4 is 32. 8 times 5 is 40, which is 4. 8 times 6 is 48, which equals 12, which comes back to 3. 8 times, where am I at now? 8 times 7 is 56. 5 plus 6 is 11, and 1 plus 1 is 2. And 8 times 8 is 64, which comes back to 1. 8 times 9 is 72, which comes back to 9. So in other words, my 8 in single digits is going 8, 7, 6, 5, 4, 3, 2, 1, 9. It's a mirror image of this in that when my 1 is positive, going up in 1s, my 8 is negative, going down in 1s. If my 8 was positive, going in this direction, which would still, incrementally be down in 1s, my 1 would be negative, going in the opposite direction. So any one of these numbers that equals the 9, separated from each other, if they equal 9, they have different polarity. 1 is positive, and 1 is going to be negative. Okay? We're modeling here, I should say, what we're looking for is mathematical perfection. There can be no spaces, no gaps, nothing omitted, nothing left out. So let's take a further look into that perfection. Let's go to 2. Okay? 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. We're coming back to 1 here. 1 plus 0 is 1. 12, which is 3. 14, 4 plus 1 is 5. 16, 6 plus 1 is 7. 18, 8 and 1 is 9. I could go to 20, but I'm back here. 22 comes back to 4. 24, back to 6. So no matter how far I go, it's going to repeat the same pattern. 2, 4, 6, 8, 1, 3, 5, 7, 9. Well, let's look over here. Now we know if my 2 is positive, going up in 2s, my 7 is going to have to be negative, going down in 2s. Well, 7 times 2 is 14. 4 and 1 is 5. 7 times 3 is 21. 2 plus 1 is 3. 28. 2 and 8 is 10. 1 and 0 is 1. 28. Then we've got 35, which is 8. 42, 6. 49, which comes back to 4. Okay, and then 56, again 2. And 63, which just comes back to 9. So while my 2 is going up, 2, 4, 6, 8, 1, 3, 5, 7, 9, always up in increments of 2, my 7 is going down in increments of 2. 7, 5, 3, 1, 8, 6, 4, 2, 9. Always beginning and ending with my 9. It is the beginning and the end of everything. It always forms the impetus and the conclusion of every sequence. Notice any distance I go out, I've still got numbers that equal 9. I have 8 and 1, 7 and 2, 6 and 3, 5 and 4. Same thing, 7 and 2, 5 and 4, 6 and 3, 1 and 8. No matter how far I go, they always equal 9. Let me skip the 3 and 6 for a moment. Let's just do our 4 and 5. We have 4, 8, 12, 2 and 1 is 3, 16, just 7, 20, 24, 28, 32, 36. Okay? All reducing back to this pattern. 4, 8, 3, 7, 2, 6, 1, 5, 9. So if my 4 is positive, moving up in increments of 4, my 5 is going to be negative, moving down in increments of 4. If my 4 is negative, my 5 is going to be positive. Okay, 5, 10, 15, 20, 25, 30, 35, 40, 45. So these are mirror images. They are showing, if you look at this one this way, if I was to hold that up to a mirror, what you would see is this one going this way. So that's what I mean when I say mirror imaging, if there's any confusion, because they don't, this isn't a 7 here and a 7. Some people have said that when you're looking at mirror imaging. But in other words, if I hold up this sequence in a mirror, what I'm going to see is this, with the exception of the 9 being on the other side. Okay. So how about my 3 and 6? What about those? Well, let's look at the multiplication tables. Let's start with 3. 3 times 2 is 6. We know that. That's the same as doubling. 3 times 3 is 9. 12, which comes back to 3. 15, back to 6. 18, back to 9. 21, 24, 27, 30, 33, 36. Doesn't matter. It's going to make the same pattern. 3, 6, 9, 3, 6, 9, 3, 6, 9. 6 is going to do the same thing reverse. 6 times 2 is 12, which is 3. 18, 24, 30, 36, 42, 48, 54. 639, 639, 639. So these are all the multiplication tables. No matter how far you go out, this pattern will repeat in any multiplication series known to man. What about the 9? I don't have that one going in multiples. Well, how come? Because no matter what you multiply 9 by, it always equals back to 9. 9 times 2 is 18. 27, 2 and 7 is 9. 36, 9. 45, 9. 54, 63, 72, 81, 90, 99, 108. You can go on forever. They always reduce back to the number 9. It is the never-changing and eternal number 9. And it's creating all the multiplication series. I say it's never-changing. In some senses, that's not exactly true. In terms of multiplication, the number 9 never changes. But you remember, I said we're going to do all the functions of math here. And we know that there is another way that the number 9 can change, and everybody knows. Okay, but it hasn't been discussed much in this mathematics. So we did multiplying. We can see that pretty clearly. One principle you should remember in this math is that whatever's going on in this higher world, represented by my 9, 3, and 6, this higher trinity here, is mirrored in the lower world. But it's kind of in a, when we say mirrored again, we mean it's kind of in a reverse direction, or a mirror flow. So to me, when I think of this, when the higher world is dividing itself, this world, this physical world, is multiplying. And those two functions are very interrelated. So let's look at division. Now first I want to start with the numbers we have in the physical world of creation, which are only 6 numbers. 1, 2, 4, 8, 7, and 5. Those are the only 6 numbers which physically exist in the world of creation. All right? And they form the underlying geometry of creation, which is essentially hexagonal. One of the most prevalent common forms seen in nature, the hexagon, whether it's the polarization of light, which can be modeled in this mathematics, whether it is the polarization seen in crystals or snowflakes. Every snowflake, even though they're all said to be unique, is basically a hexagon. Okay? So these 6 numbers form this hexagonal underpinning geometry of the physical world. Well, we saw what happens when we multiply them. They form mirror images. When you divide them, they actually do the same pattern. But there's a simple rule, and I have to show you another principle before I can explain that rule to you. And so we looked at doubling. The next principle I'd like to show before we do division is something called reciprocals. Very well-known concept in math, hugely significant concept when it comes to physics, a hugely significant function of math. Reciprocals. So how do we model reciprocals here? Okay. I want you to notice, first of all, my 9 here splitting into there's 3 and 6. It's highly significant to this symbol. First of all, if I take my 1 to my 2, notice it's at the angle of the 9 to the 3. 1 plus 2 is 3. Okay. 9 plus 3 is 3, by the way. 8 plus 4, which is at the same parallel angle, is 12, which is 3. 7 plus 5 is 12, which is 3. 6 plus 6, where we end here, is 12, which is 3. All of those at the angle of this, my 3, which is my field. This field, okay, is separating out. We call it a flux field. You could think of it, the closest thing known to it is a magnetic field. It is just spreading everything out. So I have 3 going this way in parallel lines. I have 6 going the other way. 8 plus 7 is 15, which is 6. 9 plus 6 is 15, which is 6. 1 plus 5 is 6. 2 plus 4 is 6. 3 plus 3 is 6. Everything moving at this angle is 6. So when I follow this symbol, I'm really going 3, 6, 3, 6, 3, 6. I'm showing that oscillation underlying this process of doubling. All right? So if I take my 1 now, I know if I go 1 times 1 is 1. Right? Let me move from here. One direction going each way. I get to 5 and 2. Very significant when we actually learn about the original equation of this, which was composed of 1, 2, 5, and 1. But we won't go into that now. 2 times 5 is 10. 1 plus 0 comes back to 1. Let's go another one. 4, 7. 7 times 4 is 28, which equals back to 10, which equals 1. Okay? If I go up again, I get to 8 times 8, which is 64, which comes back to 1. Now if I switch, I'm just going to go back to the same numbers, 7 and 4, 2 and 5, and then they're going to come back to 1. What I'm showing here is called reciprocals. All right? They're always separated in a certain way, and they always come back to the number from which they started. So if 1 times 1 equals 1, every direction I go, 2 times 5 is 1, 7 times 4 is 1, 8 times 8 is 1. They're forming reciprocals that always come back to 1. It's very important in modeling sound, because this is the way we're going to model reciprocal motion, or something which we'll call shearing. All right, but just so we don't lose you, let's look at that in terms of another number. Let's take 2. 2 times 2 is 4. 4 times 1 is 4. Okay, I'll come here and here. 8 times 5 is 40. 4 plus 0 is 4. 7 times 7 is 49. 9 plus 4 is 4. Okay? So no matter which way I come here, they always reduce back to my original product, which was 4. How about 4? 4 times 4, and I'll explain to you why am I saying 1 times 1, 2 times 2, 4 times 4. It's because there's actually an energy coming out here which is activating these numbers, giving them functions. In this system, whereas in regular conventional math, the functions are held still in the center of your equation and the numbers move around. In this math, the numbers are still. We could call them stationary vector interstices. The numbers are still, but the functions move, which is more like reality when we see functions are actually abilities, capabilities, and they are modeling motion. All right? But back to what I was saying, 4 times 4 is 16. 6 plus 1 is 7. Okay? I'm going to go here. 2 times 8 is 16. Again, back to 7. 1 times 7 is 7. 5 times 5 is 25, which is 7. You can do that for any number. I'll just do them quickly. 8 times 8, 64 comes back to 1. 7 and 4 is 28, back to 1. 2 and 5 is 10 is 1. 1 and 1 is 1. 7 times 7 is 49, which is 4. 8 times 5 is 40, is 4. 4 times 1 is 4. 2 times 2 is 4. 5 times 5 is 25, which is 7. 7 times 1 is 7. 8 times 2 is 16, which is 7. 4 times 4 is 16, which is 7. These are called reciprocals. Okay? We're just going to start with 1 as my control. All right? So if I'm talking about a system where 1 is my control, then my reciprocals are going to be 2 and 5, 7 and 4, 8 and 8. Now the reason why I explained all that, I said we were going to talk about division. We talked about multiplication. We understood that. What does it create? It creates doubling, creates halving, it creates mirror imaging. We get polarity, which we haven't fully explained. We get all these properties from multiplication. Well, how about division? Dividing by any number, here's a principle for you to write down. Dividing by any number is exactly the same as multiplying by its reciprocal. All right? So in other words, if I am multiplying, let's say, we could say by 1. If I'm multiplying by 1, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Just like I showed here. 1, 2, 3, 4, 5, 6, 7, 8, 9. How about if I'm dividing by 1? Well, if we start, we'll see this same kind of thing. 1 divided by 1 is 1. Okay. Let me just read these out because I have it all written down. It'll make it go faster. Okay, 1. Sorry, actually I should be saying dividing by 1. Yeah, so 1 divided by 1 is 1. 2 divided by 1 is 2. 3 divided by 1 is 3. 4 divided by 1 is 4. 5 divided by 1 is 5. You get the point. 6 divided by 1 is 6. 7 divided by 1 is 7. 8 divided by 1 is 8. 9 divided by 1 is 9. All right? So whereas my because 1 and 1 is its own reciprocal here. In this system where 1 is my control, I said 1 times 1 is 1, then you have 2 times 5 is 1, 7 times 4 is 1, 8 times 8 is 1. So 1, just like 8, is its own reciprocal. So if I'm multiplying by 1, when I divide by 1, I'm going to get the same thing. When I multiply by 1, I get 1, 2, 3, 4, 5, 6, 7, 8, 9. When I divide by 1, I get 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, just to make it a little bit more thorough, let's try it 2. So now here with 1 as my control, 2 and 5 are going to be reciprocal. So when I multiply by 2, I should get the same thing I get when I divide by 5. Okay? Just like doubling and halving, even though they're a little bit different. So let's see. 2 multiplications go 2, 4, 6, 8, 1, 3, 5, 7, 9. So dividing by 5 I have 1 divided by 5 is 0.2, which is 2. 2 divided by 5 is 0.4, which is 4. 3 divided by 5 is 0.6, which is 8. 4 divided by 5 is 0.8, which is 8. 5 divided by 5 is 1, of course, which is 1. 6 divided by 5 is 1.2, which equals 3. 7 divided by 5, you can see here, is 1.4, which equals 5. 8 divided by 5, 1.6, which equals 7. 9 divided by 5 is 1.8, which equals 9. Okay? So in other words, just like I have multiples of 2, 2, 4, 6, 8, 1, 3, 5, 7, 9, dividing by 5 gives me the same thing. 2, 4, 6, 8, 1, 3, 5, 7, 9. All right, I hope that's clear. Let me try just another example. Well, let's try multiplying by 5 then. The same thing should work. When I multiply by 5, I get 5. Let me put my other poster up here. This will make it a little easier to see the sequence that way. I don't have to be too confusing. Multiplying by 5, I got 5, 10, or I guess it's 5, 1, 6, 2, 7, 3, 8, 4, 9. I'm going to assume everyone's following me with the reducing to single digits now. I think we've covered that pretty well. So then dividing by, dividing by 2 should be multiples of 5. Very easy to get tricked up, slipped up here. But let's see. 1 divided by 2 is 0.5, which gives me 5. 2 divided by 2 is 1. 3 divided by 2 is 1.5, which equals 6. 4 divided by 2 is, of course, 2. 5 divided by 2 is 2.5, which equals 7. 6 divided by 2 is 3. 7 divided by 2 is 3.5, which is 8. 8 divided by 2 is 4. 9 divided by 2 is 4.5, which equals 9. So in other words, dividing by 2 is the same as multiplying by 5. You're going to find the same thing with 4 and 7. I won't continue to do all these for you. You can do them for yourself. But multiplying by 4, you're going to get the same as you get when you divide by 7. Dividing by 7 has actually been one of those riddles of math. You can actually solve it with this and show it to be perfect, but I'm not going to go into that here on this video. Okay, but you can work that for yourself out. Multiplying and dividing is the same given reciprocals. So that's why I was explaining in the beginning reciprocal motion. But let's go back to my 3, 9, and 6. Now I said when my number 9, no matter what you multiply it by, it's always the same, the never-changing number 9, in terms of its multiplying function. But when you divide 9 by 9, something interesting happens. So let's try that. 9 divided by 1 is 9. So we still have our 9. 9 divided by 2 is 4.5, which equals 9. So we still have 9. But then something interesting happens. When I divide 9 by 3, I get 3. So there we actually do see a function which changes the number 9. So the first number we have is a 3. 9 divided by 4, I believe, is 5. Let me just double check my math so I'm not giving wrong numbers. 9 divided by 4, oh, I didn't write them down. I believe it's 5.4. Anyway, it equals back to 9. What is it? It would be 4.5. 4.5, yeah. 9 divided by 4 would be, no, it would be 2. 2.25? 2.25 is what it is, yeah. Which would equal 9. 9 divided by 5 comes back to equal 9. Then again, when you divide 9 by 6, something interesting happens. You get 6. Okay, so now we've had a 3 and a 6, showing how it is that the 9 is initially dividing into these polar forces, which we see as magnetism. And remember again when I said, when this higher world of the 9, 3, and 6 is dividing, you get multiplication in the physical world. A very interesting concept which has not been pointed out here before. Okay, 9 divided by 7 comes back to 9, 9 divided by 8 comes back to 9, and 9 divided by 9, and here's the magic trick, gives you 1. So the only numbers that seem to have this ability to cross between one world and the other are what? 9, 3, 6, and 1. Okay, this is why we say one God, one universe. In order for anything to be coherent, which is certainly a property we're looking for in energy and nature, coherence, communication, it has to be unified. 1 is the only number which can cross the boundary between this world and the higher world. It is certainly the only number which has the full capacity for channeling this energy of the 9, which is absolute wholeness, completeness, filled up to the top. That is the 1. So I want you to pay attention to the fact, too, that there's a very specific relationship between how this 3 and 6 relate to the 9 and how the 2 and 5 relate to the 1, or any reciprocals for that matter. The function of the 9 splitting into the 3 and 6 is directly related to reciprocals in the physical world, which are modeling motion. Okay, so we did multiplication, we did division. Add and subtract is pretty easy. If you're adding any number, you're just going up in increments of that number. If you're subtracting, you're going down in increments of that number, which is the same that I just showed in my multiplication series. The only other thing I didn't show, and I showed reciprocals there. Now, I didn't talk about my 3 and 6. What happens when you divide by 3 or 6? Well, something interesting happens, and it leads me into my next topic here, which is something we call family number groups. Now, I'll just give you quickly, you get repeating decimals when you do this, but there's a way to solve this and show them to be whole numbers. Okay? If people are very interested in that, I'm not going to take the time to do it right now. I can show that. If people want to write comments on the video, I will try to get the solution up. You can see I have my numbers and all my work written out here, which I'd be happy to go through, but it's too long of an explanation now. But something interesting happens. 1 divided by 3, I get this number, 0.333. I get these repeating digit numbers. But let's try to find a whole number first. I know 3 divided by 3 is 1. Okay? I know 6 divided by 3 is 2. And I know 9 divided by 3 is 3. So I use that at first to set up my numbers. Now, the way that we do this here is, if you notice here, for instance, 5 divided by 3, I get this number 1.666667. And I'm saying that equals 5. Well, why is that? Well, if I look up here at 2 divided by 3, I have this number 6666667, which equals a 4. And 4 plus the 1 here will give me 5. I can find this pattern same. This has to do with polar number pairs, these numbers that I'm showing. But again, it's a little bit complex for what I'm trying to explain here, and I don't want to get too bogged down in it. But what happens when I multiply by 3's? 1 divided by 3 gives me 7. 2 divided by 3 gives me 4. 3 divided by 3 gives me 1. Okay? 4 divided by 3 gives me 8. 5 divided by 3 comes back to 5. 6 divided by 3 equals 2. 7 divided by 3 equals 9. 8 divided by 3 equals 6. 9 divided by 3 equals 3. The same thing is going to happen when I divide by 6 by backwards. Now, don't be worried if you're losing me a little here. I'm about to explain this. 1 divided by 6 is 8. 2 divided by 6 is 2. 3 divided by 6 is 0.5, which is 5. 4 divided by 6 is 4. 5 divided by 6 is 7. 6 divided by 6 is 1. 7 divided by 6 is 9. 8 divided by 6 is 3. 9 divided by 6 is 3. So in my first group, dividing by 3, I have 7, 4, and 1, 8, 5, and 2, 9, 6, and 3. Okay? In my second group, dividing by 6, I have 8, 2, 5, 4, 7, 1, 9, 3, and 6. All right, what does that mean? What am I trying to show there? It seems a little bit fuzzy, not the same clear sequence we started with in a lot of these. So again, I have these groups of numbers, 1, 4, 7, 2, 5, and 8, and then my 3, 9, and 6, which are easy to see here as a group. They were linked together in groups of 3. All right? This is another property that we get from this dividing process. All right? They're called family number groups. Let me say them one more time. The family number groups are 1, 4, 7, 2, 5, and 8, 9, 3, and 6. There are 3 different family number groups. Okay? How do we determine them? Well, let me give you a few ways to do it. Remember I said 3 and 6 here are my field. 1 plus 3 is 4. 4 plus 3 is 7. 7 plus 3 is 10, which comes back to 1. 10 plus 3 is 13, which comes back to 4. 13 plus 3 is 16. 16 plus 3 is 19, back to 1. Okay, no matter how far I go, if I keep adding 3's, it's the same pattern, 1, 4, 7, 1, 4, 7, 1, 4, 7. And notice these numbers are as far triangulated from each other as possible. That is very significant when we come to talking about geometry. And in this system, numbers are not modeling geometry. Arithmetic is not explaining geometry. It is geometry. Okay? And that's going to be a very simple process to understand. But first thing you notice, 1, 4, 7. If I add by 3, I always get those numbers in an unbreaking chain. How about if I go the other way? 1 plus 6 is 7. Now I'm using my 6. 7 plus 6 is 13, which is 4. 13 plus 6 is 19, which is 1. Or I could say 4 plus 6 is 10, which is 1. 10 plus 6 is 16, which is 7. Okay, 16 plus 6 is 22, which is 4. Forward motion is what the 3 is. The 3 is represented by the shape of a triangle. Okay, very easy to remember. A triangle is represented by the three sides. Adding by 3, forward motion, triangulated motion, an arrow forward, which is what this is, an arrow, a vector, is forward motion. 6 is backward motion. It's a backdraft. Okay? So when I'm going backwards, I got 6. Let's look at my other group. I said it was 2, 5, and 8. 2 plus 3 is 5. 5 plus 3 is 8. 8 plus 3 is 11, which is 2. 11 plus 3 is 14, which is 5. 14 plus 3 is 17, which is 8. No matter how far I go, adding 3 is the same. 2, 5, 8, 2, 5, 8. 2 plus 6 is 8. 8 plus 6 is 14, which is 5. 14 plus 6 is 20, which is 2. 26, which is 8. On and on. Backwards, 6. Forwards, 3. So if 3 is an arrow moving forwards, or a triangle, 6 is the backdraft balancing or giving equilibrium to that, which is called a hexagon. 6-sided figure. A hexagon. Just like I said, ultimately, this underpinning geometry, because I have a family number group oriented this way, I have one going this way. Always polar opposites are accounted for. Then a 3, 9, 6 is the same. If I go 9 plus 3 is 3, 3 plus 3 is 6, 6 plus 3 is 9, so on and so forth. You can do backwards. 3 plus 6 is 9, 9 plus 6 is 6, 6 plus 6 is 12, which is 3. They're related in the same way. All right? So this is how we start to look at things as polarized. All right? So you remember when I said these pairs going straight across. By the way, if I draw straight lines across this from here to here or here to here, okay, or here, if I'm drawing across like this, straight lines, you'll notice that everything is equal angular triangles. In other words, this isn't, I should say, this drawing is hand-drawn. It's not exactly precise, but this, if they were lining up, they should make perfect equal angular triangles here. All of these are triangles, all right? Never connected at the base, though. They're only connected at the vertex, or the apex, at the point. So important. I can't emphasize how important that is in this math. Okay? Getting down these essential principles is how you do the advanced stuff. If you don't know what I'm talking about, you'll never get there. You can play with the toroid all day. You're just kidding yourself. All right? So when my 1 is positive, my 8's going to be negative. And these family number groups are always positive or negative at the same time. All right? They're showing synchronization. All right? When we do electricity with this, we're looking for synchronized electricity. Everything in reality is synchronized and controlled by its center point. All right? So this is the source of synchronicity. So when my 1 is positive, my 8's negative. Then I know my 7 is going to be positive, my 2 is negative. My 4 is positive, and my 5 is negative. So when my 1, 4, and 7 are positive, my 2, 5, and 8 are all negative. All right, why is that significant? In other words, if I have an arrow going forward one way, I'm going to have a backdraft going back in the opposite direction. Just like when you watch water flowing down the street, it forms a diamond. Okay, from a triangle going forward, you get a backdraft. And when I said my 3 is a triangle, my 6 is a hexagon, the 9 is a perfect diamond, which you see right here in this space. So we showed our family number groups of 1, 4, 7, 2, 5, and 8, 3, 9, 6. We showed how they're separated by thirds or separated by sixths. They're never separated by anything else, by the way. We showed that they're represented by this geometry of triangulation, of the hexagon, even of the diamond. Why is it significant, and why are those numbers, why do they have to be positive or negative at the same time? Well, one, I showed that it accounts for the geometric side of what we're going to do. In addition to that, those numbers being synchronized in such a way or being activated at the same moment. Okay? In engineering, we could call it a moment of activation, a pulse. That's what allows me to get a binary flip-flop. Okay? Because we're working with something we're going to call a binary triplet. I'm going to explain what that is. Now you notice I have these triplets in my family number groups. But I also have something binary here, which is my 1, 2, 4, 8, 7, 5. The repeating sequence underlying the binary code of computer science. And when my 1s, 4s, and 7s are all positive, and let's say my 2, 5, and 8s are negative, I've got positive, negative, positive, negative, positive, negative, positive, negative. In other words, I have my binary flip-flop from positive to negative, never being broken. Same with my 2, 5, and 8s. I have positive, negative, positive, negative, positive, negative. And what that means is ultimately, I don't need 9 now to represent my system. I really need 18 because there's a positive and negative for every number. Every number has the potential to be polarized. All right? How about my 3, 9, and 6? Because this is weird. Now I've got this thing. I got to come to my 9 before I can go back. So how to create that? In this system now, when my 9 is positive, which is the initial emanation, the projection, the initial will, the initial drive, the initial input of energy, my positive 9. When my 9 is positive, my 3 and 6 are negative. So in other words, when this energy is coming out, magnetism is going in to the center. When this energy is absent, or you could say when it's going in or when it's absent, when it creates a pivot, which is my -9, and my 3 and 6 are both positive coming out. And then what that does is it gives me, let's say my 3 is positive, a positive, negative, positive. Whenever you end on a number in this system, you give it the reverse polarity and you go in the other direction. So if I go positive, negative, positive, my next number is going to be the -6, which is under here. And it's going to go negative, positive, negative, positive, negative, positive. Okay, so it's giving me a sequence here. It's 3, 9, 6, 6, 9, 3, all right, alternating back and forth. When we put this in a three-dimensional model, you're going to understand exactly what I might mean by that. So what I'm showing here is a pulse. The 9 is a surge. Sometimes you can refer to it as an inertia ether, which Einstein postulated after the famous Michelson-Morley experiment that supposedly disproved the existence of an ether. Einstein said, well, if it's not that, it must be an inertia ether, and that's what this is. It's a pulse or a surge or a vector that's driving everything, that's causing this doubling. Okay? So again, now I need 18 numbers to represent my system, each number having a positive and negative, and each family number group, there's 3 of them, okay? They're nothing smaller than groups of 3 in this system. There's 3 family number groups, and they're each activated at a moment. So if I have 18 numbers altogether to represent my system, and if only 3 of those numbers are ever positive at a time, that means only 1/6 of my numbers are ever activated or positive at a time. Okay, now if you don't follow me there, just wait, because you will when we do the torus. Only 1/6 of my numbers are ever positive. That's 1 positive family number group per 18 numbers. All right.
That's clear. When you're saying 18 numbers, are you saying you'd have 18 around the, instead of 9?
Not 18 around the circle, but 18 because this is a positive 9. There's really a -9 behind it. This is a positive 1. There's really a -1 on the other side. So again, this is just a 2-dimensional cross-section of a circle, but it's explaining what we're going to see in 3 dimensions. Okay? So I think I covered most of what I wanted to say there. The only thing that I wanted you to see now is, what is this really doing? When we get to this in physical reality, well, if you look at this shape closely, and I will show, it's actually the shape of your DNA spiral helix. Even the DNA that your life is operating on is based on this shape. It's a coil. Everything physical is a coil. It's conducting an energy, which is this. If the more high inductance it is, the better it conducts this energy, the more alive it is. The number 9 is perfection, consciousness, the apex of consciousness, full 100% consciousness. And when we work with sound, and we work with numbers, that's what we're trying to do. 100% full efficiency. Whether it's our pathway of motion, whether it's electrical efficiency, everything is interconnected. And it's connected from here, the 0 point. 0 is not a number on any multiplication series. It's an absence. It's a hole in the center. And what this is a vortex. It's compressing things, sucking them in at the top, decompressing them, shooting them out at the bottom. Okay? It's a cosmic grinder. You could think of it as black hole to white hole, compression to decompression. Your own body, the human torso, the mortal coil, is based on this. It sucks things in at the top, whips them around, demolecularizes them, shoots them out at the bottom. All right? Everything is based on that. The Earth's magnetic field, it's called a torus. The human aura is said to be a torus. The spiral galaxies are toruses. Your blood cells are a torus. You will get to know that very clearly. Let's look again here. If I take into account all these multiplication tables and I look at them as a sequence, I'll notice something very interesting is happening here. Now here's my first control. I should say this, a very basic point. Multiplication tables, or as we've seen, similarly division tables, okay, are two things. They can either be straight lines or circles. It doesn't get any more easy than that. Multiplication tables are straight lines or circles. It's pretty easy to see. We can see the straight lines here. I don't think anybody's having a problem there. Multiplication tables are modeling straight lines. Okay, increments of straight lines. What do I mean they're showing circles too? Well, in my initial symbol, remember I said 1 was my control. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 around the circle. How about if I start with 2? 2, 4, 6, 8, 1, 3, 5, 7, 9, just like my multiples of 2. 3, 6, 9, 3, 6, 9, 3, 6, 9. Multiples of 3. 4, 8, 3, 7, 2, 6, 1, 5, 9. Just the same as here. 4, 8, 3, 7, 2, 6, 1, 5, 9. So in other words, you can do it any way you want. They're either going out in straight lines or they're going around in circles. Both those conditions must be met simultaneously in order to have a true system. And this is why time cannot move backwards. Okay? This is why this system is creating a one-way systemic living flow. It's called a positive flow. The energy of the 9 is a positive force. The reality of the higher world is a 100% positive reality. 100% goodness, divinity, if you will. 100% positive energy. What we experience as negative is a result of that energy moving into this world, creating a backdraft, if you will, a mirror imaging. All right? So multiplication tables are straight lines or they're circles. Now that creates, notice my doubling never breaks. 1, 2, 4, 8, 7, 5. Let's go out one more. 2, 4, 8, 7, 5, 1. Right? 4, 8, 7, 5, 1, 2. They're changing position even though they're really not. I'm just looking at different controls. But my doubling circuits are always in a one-way flow. They're always moving like this. Doesn't matter where I start. Even if I start with my 1, here I'm going 1, 2, 4, 8, 7, 5. It's never breaks this one-way flow. Even though this energy, I say, it moves omnidirectionally. In other words, it comes from the center of everything out, from the center of every atom, from the center of the Earth, from the center of the solar system. Any body of mass, any body of mass in equilibrium has this energy coming out of its center and synchronizing everything that's connected to its body. All right? The Earth could be an example of that. So as this energy comes out in all directions, it's pulsing everything forward. It's also causing disintegration. What you could observe in some cases is radioactive decay, which is based on doubling or half-life. It's why this is why we always have to eat to stay alive. Because it's a systemic living system. It can never, the last thing you want it to do is to back up. Okay? Backing up is the equivalent of death. It puts an end to the positive flow. So let me show you in my book here, again I'm sorry for these poor illustrations, just finally what we have here and what I'm trying to explain to you and show you on the symbol. And then we're going to move to a better, more dimensionalized model. Okay, so just a few things, final things we could explain. Here I'm showing controls. Okay, so this is what I was just explaining. My first one is in multiples of 1. So I have my 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. The same thing you're seeing on the symbol up there. I could just as easily do a control of 2. 2, 4, 6, 8, 1, 3, 5, 7, 9. Notice my doubling circuits never break. I still have 1, 2, 4, 8, 7, 5 moving in the same direction. All right? I could have 4, 8, 3, 7, 2, 6, 1, 5, 9, multiples of 4. Still my doubling circuits, 1, 2, 4, 8, 7, 5, still moving in the same direction. I could do 8, 7, 6, 5, 4, 3, 2, 1, 9, still 1, 2, 4, 8, 7, 5, 1, 2, always moving in the same positive flow direction. All right? These are examples of what I mean when I say you can't move it in the other way. Because if I do, I never get my multiplication tables. Look here. Here I would have it, instead of going in this positive flow, I'd be going backwards. 1, 2, 4, 8, 7, 5. Well, I still have a doubling circuit. I still even have my numbers equaling my field. I still have my polar number pairs, but what's the problem? I even still could model my family number groups. But if you go around the perimeter of the circle, I no longer have a valid multiplication series. This is not any of the multiplication series. Okay? This is just another example of one that wouldn't work. Even though they're equaling the field and everything is, I still have no multiplication series around my circle. So you must account for every single principle in the circle. Let's see what else I have here. Because this is what it's doing. And I'm going to show you this in the numbers. Ultimately, this right here is how these numbers are modeling motion. It's something coming in at the top, it's inverting, shooting out the bottom, coming back around in a living, stemmic vortex. Okay? All right. So again, it's modeling this motion out at the bottom, in at the top, inverting, just like this. It is, let me show you how that occurs in the numbers. Because all this is a perfect waveform. Anytime you have a waveform, you're going to have nodal points, crests, dips, okay, hills and valleys, curves and curls. And anytime you have nodal points, you got a number. So every time you have a crest in your wave, you've got a number. All right, and that's what these numbers really are. Again, you can call them stationary vector interstices if you want to give it a pompous sounding name or a high science word. Okay, let's look at how these numbers are making a vortex really quick. So here in my first stage, 1, 2, 3, 4, 5, 6, 7, 8, 9. What's going to happen in my second stage? Well, you notice my 2 just goes up. My 7, it just goes up. In fact, my 4 just goes up. 4 goes up here next to 2. My 5 goes straight up next to 5. But what happens to my 8 and 1? Well, if you look, my 8 ends up over here. My 1 ends up over here. Because what happened is they actually inverted. All right, what if I go to my next stage? Well, then notice my 8 just goes straight up. My 1, it just goes straight up. All right, I could say the same thing. My 4 and my 5 that were here just went straight up. I know this is a little confusing to look at, but you have to go look at it from stage to stage. But if I have, say, my 2 and 7, whenever they reach the top on my next stage, notice 2's over here, 7's over here. So what they're doing as they multiply is making a vortex. It's coming in, every third it inverts. Okay? Whenever it crosses the center, whenever these numbers cross the 0 or cross through the hole, they invert. They turn upside down. They reverse the mirror image. And that is what this is modeling. Okay? So I've accounted for all the principles we had. We've got family number groups. We've got reciprocals, multiplying, dividing. We've got addition and subtraction, which is how things get, by the way, a positive or a negative as a sign symbol that we're familiar with. This energy is what imparts the positive motive momentum to everything. it is a positive force, right? which is ultimately what everything is based on. It's creating a duality, which is really part of a trinity. You could think of the 3 and 6 as male and female. Again, and the arrow, the straight line towards the balanced equilibrium of the 6. All right? So, oh, right. One more thing I should do, powers of 10. I don't have a board for that, but I think everyone will be able to follow me. This was the last thing of our symbol, just to be a little more thorough, powers of 10. Because not only am I showing doubling here, but I'm showing, when you draw numbers, when you have 100, 1,000, 10,000, we put the comma with every third number. That's not just arbitrary. Numbers themselves aren't just arbitrary. We don't have 10 at base 10 because we count on 10 fingers. These numbers are actually conditions for creation. All right? They're not only just quantities, but they're qualities. They have aspects. They have ratios. Everything in number is an angle and a ratio. In other words, where is it moving? What's its direction of travel? And how much of it is there? Angle and ratio. So, what was I saying? Oh, powers of 10. So, if I take 1, then I have 1. Half of 1 is 0.5, right? But really what we're doing is, this is really 1 over 1. This is going to be 5 over 10. So I'm going to have my tens placed here, 0.5. Then I'm going to go to 0.25, which is really 0.225 hundredths. Or it wouldn't be 0.20, but it'd be 25 hundredths. Then I have 0.125, which is thousandths. 0.0625, which is 10 thousandths, again aligned with my 10. Then I'm going to go to 100 thousandths, which is aligned with my 100. Then I'm going to go to a millionths,